Welcome to Lesson 8.2, Measuring and Classifying Angles. This might be a bit of a review for you today. However, we're going to go over it just to make sure that everybody's on the same page, so that way when we move on to 8.3, nobody's left behind. All right, as always, we need to start off with that vocabulary. First word that we have to define, angle. An angle is a figure formed by two rays with a common endpoint. Again, a ray is a geometric figure that has an endpoint and continues on without end in one direction. So an endpoint and continues on in one direction. An endpoint continues on in one direction. An angle is formed by two of these rays that meet together here. We call this point where they meet the vertex, the point of intersection of two sides of an angle or a figure. Okay, so when you're drawing your example, I want you for angle just to draw this. And then for vertex, I want you to draw the angle, mark the vertex. You don't have to make it quite as big, but then I would draw an arrow pointing to this so you know that that is the vertex. All right. Moving on to your notes. Today we are going to work on measuring angles and reading a protractor, so you will need a protractor. When we're working with this, we're going to pull out our protractor. Okay, and the first and most important part is always to make sure that you have your protractor lined up on the vertex, right in the center, like I do here, and then to have this bottom line on the bottom line of your angle. The first thing we're going to do is we're going to look at this angle and we're going to name its vertex. So this angle meets at point B, which is our vertex, and then we could name this angle A, B, C. And it makes sense because we start at A, we can go to B, which will then connect us to C. You could also name it angle CBA. However, you cannot name it angle ACB because there's no line connecting A to C. So imagine it's like line tag. If you start at A, you have to go to B in order to get to C. Okay, the size of this angle, and I'm actually going to make my protractor a little bit bigger here so we can read the numbers a little more easily. We have to make sure to start at the right number. So in this case, we wouldn't start at 180 degrees because that's not what number we start counting at. We start counting at 0. So we count at 0, and we have to make sure that when we count, we're counting the right numbers. So we go from 0 to 10. However, this red line doesn't get to 10, it actually only gets to 9. So we would say that the size of this angle is 9 degrees. Okay, then angle 2, we have angle FED, or we can name it angle DEF. The vertex in this case is E. Then we're going to place the center of the vertex with the center of the protractor. Now in this case, again, we're starting at 0, but we're reading the outside numbers because that's where the 0 starts. That's right there. So we go 0 to 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. We don't get quite to 120, but if we look very closely here, you'll notice it goes past 115, so we count each one, 1, 2, 3, 4, 5, and we actually get to 16. So angle FED is 116 degrees. Now this is where it gets a little tricky because you'll notice that there are several different angles here and we have a lot of space left on this part of our graph. So If we start at H, we know that K is going to be the vertex for all of these angles. So we'll start at H and we'll figure out what angles we can make. Again, it's just like line tag. I can follow H to K and then get me to J. So I have the vertex K, and then I have angle, which is the symbol, H, K, J. And even though we have so many different angles here, it's the same thing. You take the protractor, put it in the center of the vertex, line up your bottom line of your angle with that line on your protractor. Okay, we have the outside number starting at 0, so we follow it until we hit our next ray. And in this case, it's at 30 degrees on the nose. So angle HKJ is 30 degrees. I'm going to move this protractor. All right, then I'm going to follow, and I always start with the same point because it helps me know what I've done already and give me a starting point and an ending point. So now if I have H and I follow it to K, it can also connect me to L. So K is still my vertex, and the new angle that I get is H, K, L. So we line it up. Right in the center, line up that bottom line. Again, we're using those outside numbers because that's where the 0 is. Follow it all the way around. Okay, we don't quite get to 170 degrees, but we do get to 169 degrees. Measuring angles can be very easy, but it can be very easy to confuse as well. Having to remember which numbers to use, the inside or the outside, seems simple enough, but it is a problem that a lot of students have because sometimes we just forget and we look at the numbers and we write it down. Always go back to make sure that your answers make sense. And we can talk about that when we talk about classifying angles in a few minutes here. All right, again, I start at H, and I know I can go from H to K to M. K is still my vertex, and now I have angle HKM. You'll notice that this angle is actually going to stay on that straight line. So we go from 0 all the way to 180 degrees. So this angle is 180 degrees. And because there's no other points that I can get to starting at H, I can now move on to J. Okay, so finding these angles can be pretty simple, but now because we have J on such an angle, measuring it can be a little bit complicated. And it'll be nice for you because you can turn your paper. So whenever you have the opportunity to turn your paper so your protractor isn't sideways, I highly suggest it. So if I follow, it makes no sense to go from J to K to H because we already did that up here. So we're just going to continue going clockwise. So if I go from J to K to L, I have made another angle. K is my vertex. I have angle J, K, L. So now to measure, I'm going to bring this down, put it on the center. Now I have to turn my protractor to keep that line on that bottom part of the angle. This is where it gets a little bit tricky. Now again, I have to start at 0, follow it all the way around till I get to that line that L is on, and I see that I get to 139 degrees. And we'll talk about later why 41 degrees wouldn't make sense here for an answer. But we know that angle JKL is 139 degrees. All right, starting again at J, I can go from J to K to M. K is still my vertex, giving me angle JKM. Again, we're going to put that protractor on there a little bit sideways. Line up those bottom lines. Follow the outside numbers, and that is going to get us to 150 degrees. I'm moving a little faster here now because we have practiced a lot with this now. You'll notice there's no other points that I can connect with starting at J, so now I'm going to start with L. Again, we're going to continue clockwise because it makes no sense to go any other way. So if I start at L, I can go from L to K to M. K still my vertex. I have angle LKM. And now I can turn my protractor back the correct way because I'm not sideways anymore. Put it on that center dot right there. Turn it. And need to move it a little bit. Line up those lines as best you can. Okay, and I can go from KM up to my line, and I can measure the other way, so now I have to use the inside numbers, and I see that angle LKM is 12 degrees. Now moving my protractor, I take a look. I had HKJ, I had HKL, I have HKM, JKL, JKM, and LKM. So now I know that I've found all the angles that I could with these 4 rays, and I can move on to my next page. All right, so you're going to have to go back to your vocabulary here. For some of us, this is going to be a review, but it's always good to touch up on those vocabulary terms. A right angle. A right angle is an angle with a measure of 90 degrees. Not 91 degrees, not 89 degrees. It has to be exactly 90 degrees. An angle that measures 90 degrees will look something like this. And as a lot of you know, it has that little box in the corner to tell you that it is 90 degrees. An acute angle is an angle that measures from 0 to 89 degrees. So anything that is less than a right angle. So your acute angle would look something like this. Now this is just one small example. There are lots of examples of acute angles, but it has to be less than that 90-degree angle. So it has to be smaller than this. An obtuse angle is an angle with measures from 91 to 179 degrees. So this is anything that is bigger than a 90-degree angle. Even if it's just a little bit, it's still obtuse. So an example of an obtuse angle would be something like this. Now I know a lot of us have learned that an acute angle is a cute little angle. So it helps you remember that it's a small angle. An obtuse angle is a big angle, so it's going to be your larger angles. And then last but not least, your straight angle is an angle with a measure of 180 degrees. A straight angle is actually an angle that is a straight line. I want to make sure you understand that there's a difference between a line being straight and diagonal. A diagonal line is still straight, it's just weird direction. So this is considered a straight angle. Even though it's on a diagonal, it's still considered to be a straight angle because from here to here, it is 180 degrees. All right. The next step that we are going to do is we are going to move on to creating angles. So you'll notice that I have the steps in here in your notes as well. I want you to follow along, and anything you see me do on the screen, I want you to do in your notes. You may need to stop and pause in order to stay on pace or to make sure that you can draw your angle correctly. Okay, so the first thing we need to do is we need to make a vertex. Simple enough. Somewhere you need to put a dot. Now I wouldn't put my dot over here because then you don't have a lot of space to make your angle. Okay, then the next thing we need to do is we need to make a straight line from the vertex. Okay, so we extend in one direction, put our arrow. The next thing you need to do is you need to then use your protractor, place it in the center of the vertex just as if you were going to measure your angle. Okay, now that we have that set up, we're going to measure from the straight line with the side that starts at 0. So in this case, we're going to measure with the inside numbers because that's where our 0 is. It might be different on your protractor, so you want to make sure and check. For this angle, we're going to use the example 60 degrees. So we're going to start at 0 and we're going to go all the way up to 60 degrees. Once you get to 60 degrees, you want to make a mark to note that that is where you want to draw your straight line to. Now this is going to be a little bit easier for you, but you're going to turn your protractor and you are going to line up the center of that vertex with that dot that you made at 60 degrees. The reason we do this is so we can use the straight edge of our protractor to make a straight line starting at our vertex and going out towards that 60-degree mark. I'm going to use my line tool to make sure that I make a nice, clean, crisp line. You can use the side of your protractor. Okay, so I start here. And I go past that dot, put an arrow at the end, showing that that ray goes on forever, and I have now drawn a 60-degree angle. Again, a somewhat simple process, but we need to make sure that we're taking our time and reading the right side of our protractor. For the last part of your notes, you have to draw angles that have the following measures. So you need to draw each of these angles. And then for these bottom 3 angles, I want you to classify them as either acute, obtuse, right, or straight. Again, we'll go over these tomorrow in class. If you have any questions, be sure to jot them down on the bottom and ask them tomorrow.